This is Algebra 2 with Trig, 1C.3. We're working on complex numbers. Okay, as we look at this, not all equations have real solutions. For example, if you're doing x squared equals negative 1, we think about our parabola, and we're trying to see where does that parabola cross at negative 1. And mathematically, it doesn't cross the line y equals negative 1 anywhere. So we would typically consider that no real solution, because the square root of any real x value is never going to be a negative number. But to overcome this problem, we're going to expand the system of numbers using the imaginary unit of I. So when we learn about I, we are going to have I equals the square root of negative 1. So instead of having square root of negative 1 part of your problem, we're going to remove that. We're going to replace it with I to kind of give us a notation that we did some magic work here. And we're going to continue to follow mathematics as we normally do. A little extra step. You already know that when you have the square root of 3 times the square root of 3, that answer is 3. So, very similarly, if you have the square root of negative 1 times the square root of negative 1, you're going to get negative 1. So, I times I is negative 1. So we're going to use that in our calculations. When the i's get multiplied, we'll have an exponent of 2. So if r is a positive real number, and we take the square root of this negative r value, then we're going to pull the negative out. So you're actually pulling a negative 1 out, square root of negative 1, and that's going to be I square root of r. So in this case over here, we're taking the square root of negative 3, and we are pulling the square root of negative 1 out from it. And then we replace the square root of negative 1 with the I, and it's I root 3. So we'll come down here and give it a try. So normally, we would say that x squared cannot equal a negative number. But when we take the square root of both sides, we get plus or minus the square root of negative 13. Now, instead of saying that we can't do this problem and no real solutions, we're going to take our negative 1 times 13, and we're going to turn the square root of negative 1 into an I. So now we have plus or minus I root 13.
What is the I?
So we come over here. Notice we do not have a b value. There are no b values here, no x value by itself. There's an x squared, but there's not an x value. So we can go ahead and expect to use square roots. So that's negative 90, and I take half of both sides. I get x squared equals negative 45. And I know this is going to be a problem, because when you square something, you should not get a negative answer. But instead of giving up, we'll go over here to a different dimension. And we'll take the square root of both sides. That gives us plus or minus. Remember, you're doing negative times 45 is what's happening in there. So this is negative 1 times the square root of 45. So we can consider this plus or minus I times the square root of 45. And the square root of 45 is 9 times 5. And you can take the square root of the 3, so when you do the 3, it actually comes in front of the I. And we can continue the problem, just as we always have, but instead of saying we're done, we just use the I to represent, hey everybody, this is a little weird answer, this is an imaginary answer, this is not on the number line. But we use mathematics for all the rules we know. So, now we can go into some other mathematics other than just solving equations. We're going to have complex numbers is any number that can be written as a real number plus or minus an imaginary number. A plus or minus BI. That's considered a complex number. The A value is your real value, and the BI portion of it is the imaginary value. So down here we can do some crazy math. If we have a real plus an imaginary and a real plus an imaginary, you can add the real numbers together, you can add the imaginary numbers together, and you can come up with a conclusion. Or you can subtract. So you subtract the real numbers, you subtract the imaginary numbers. So you're just collecting like terms. Imaginary are like terms, real numbers are like terms. Let's give it a try. What you need to recognize here is that even though you have parentheses, this has a plus in between. When you have a plus in between, that is telling you to add. We all know that, but when it comes time to doing multiple type problems, we start to do some crazy work. Notice that this has a plus in between. So I'm going to take my 12 minus 11i. Theoretically, I am distributing my positive through. So a positive and a negative is a negative 8. A positive and a positive is a positive 3i. So when you're adding, that doesn't change what you're adding. You're still adding a negative 8, and you're still adding a positive 3i. Now we can take our like terms, which gives us 4, and our like terms, which gives us 8i. And that's our answer. Just collecting like terms. Using all the rules you already know about. So we'll slide over here to this one. Some people get confused with the parentheses. A lot of people end up thinking that FOIL is involved with this problem. There is no FOIL involved because it's a subtraction question. In fact, this first binomial doesn't need parentheses at all. So don't get thrown off by the parentheses. I'd get rid of them as soon as you can. Here, like we did before, we distributed the positive, but it didn't change anything. When we distribute a negative, it does change things. It makes the 24 become a negative 24. But more importantly, it makes the negative 9 become a positive 9i. And we put these together, and it looks like that's going to be negative 9. And we put these together, and it looks like they're going to cross out. So our answer is just negative 9. So what's different with these questions? We are definitely multiplying involved with these. We're not adding and subtracting. So these will deal with multiplication, where the other problems dealt with addition or subtraction. All right, we know, as we discussed earlier, that the square root of 3 times the square root of 3 gives us 3. Well, at the same case, if we have the square root of -1 times the square root of -1, that should give us the value that's inside, which is -1. So be sure, whenever you see I squared, you turn it into a -1. And then we can continue on like normal. So over here, I'll just do our normal mathematics, which is taking your coefficient and distributing that value in. We get -40i, just like you would with any variable, and a positive 45. When you have I times I, you add the exponent, so it's 1i, and 1i is I squared. Just like if you said x times x, you'd have x squared. So I times I is I squared. And now we know what is I squared. Be sure that when you see I squared, you turn it into -1. So I squared is -1. You just replace the I squared with the -1. So that's going to give us a -45. Because 45 times -1 multiplies together to be -45. Then you should put your real numbers first and your imaginary numbers second. So -45 minus 40i should be written in that order. All right, our next question. What's the hints that we see and how we should handle this problem? This is multiplication. We have two sets of parentheses, so we have two binomials. We're multiplying two binomials, so that means we're going to use FOIL. We're going to multiply the front, which is the F, which is -32. O means the outer, which is a positive 56 times I. I stands for inner, so we're doing the inner portion, which is positive 8i. And L stands for the last, so that's going to be a negative 14i. And because it's I times I, it's I squared. So we have our -32 we can't do anything with. We can group our like terms together to get 64i. Now we're just using our math skills. We know that I squared is actually something else. We see I squared, we turn it into -1. So this is going to be -14 times -1. You know that when you multiply a negative number by -1, you make it a positive number. And then we can collect our like terms. What you don't want to do here is to say -14, -14. We don't have an equal sign. We're not doing the opposite. We're just collecting them as they are. So this is -18 plus 64i. Notice that neither of my answers have a negative, neither of my numbers have an I squared involved. Answers do not have I squared. I squared is -1. Get rid of the I squared. Don't give I squared like you do in a quadratic with x squared. All right, last type of problem. And you already know how to do this. We're just going to multiply by the conjugate. We're going to follow the same rules. It can be done in a problem like this as well. When dividing complex numbers, you should multiply both the numerator and the denominator by the conjugate. So remember, the conjugate of A plus BI would be A minus BI. You're going to change that sign. So we'll come down here. This takes a couple steps to do. It's a little scary, but we can do this. So what we're concerned about is having the I in the denominator. That's what we don't want. It can be in a numerator, but it can't be in the denominator. So we're going to take that amount and multiply it by the conjugate. And whatever we do to the bottom, we have to do to the top. So we're going to multiply this top portion. I'll just reorganize it so I have a little bit more room. Okay, so I'm going to get 15 plus 3i plus 20i plus 4i squared. Well, I know that that's 15 plus 23i plus 4 times negative 1. That's 15 plus 23i minus 4, and together that makes 11. So it's 11 plus 23i. That's what the numerator is. All right, now we're going to take the second example. 5 minus I. And we're going to multiply that to 5 plus I. So we do the same thing. We get our 25. And you might start noticing that this middle O and I drop out in FOIL when you're working with conjugates. But if you still need to see it happen, you're welcome to do that. So you get minus I squared. Those cross out. We know that we have 25 minus I squared is negative 1. So that's actually going to make 25 plus 1, which is 26. So this is 11 plus 23i over 26. But didn't we talk about how the imaginary numbers go second and the real numbers go first? So we're going to break this up into that fraction. We're going to break it up into that fraction. So 11 over 26, because the real numbers go first, and the imaginary numbers go second. We're writing our answers just like we did up here. We reorganized it so the I went second. We're going to rewrite it so the I goes second.